Hey, welcome to Lesson 15, and today we're looking at solving polynomials with technology. So you've been practicing with factoring throughout this entire unit, and now I'm going to tell you that most real-life situations aren't factorable. There are times where, in fact, it does work, but let's deal with the times it doesn't work. So today's goal, when I'm presented with an unfactorable polynomial, I can use the appropriate technology to determine the roots and solve the presented equation. So let's do a bit of a recall, and I'll do that over to the side here, just on terminology. Remember that our x-intercepts are also known as so it could be the roots of the equation. Okay, if we are looking for the solution, it could fall under that. Okay, so x-intercepts, roots, solution, regardless of what word is used here, we are in fact using this exact same process, and you're finding the exact same thing. All right, so that's kind of off to the side here. So we're going to be using the graphing calculator for the technology. Depending on the program you go into, they might give you a software program to use. So it really depends, and in this course in Ontario curriculum, we end up using the graphing calculator. So what's our process? Once we determine it's unfactorable, first one is to enter equation on the calculator. Now you can get emulators so that you can practice with this at home. If you're in the classroom, you'll have access to the graphing calculator, so it's not a big issue. So enter the equation on the calculator. Your second step then is to graph and adjust the window. Adjust the window. And then, and I'll put this over here, back at the recall, it's also called the zeros, the graphing calculator. I forgot the third term there. Okay, x-intercepts are also known as the zeros. So use the zeros option. Under calculations, to find the roots. Now this is going to take practice. You're going to need to know how to use the calculator for a test in the exam, and we're going to be using the calculator extensively in the units coming up, so you might as well get comfortable with it. So I have two examples on the next page here, and I'll take you through step by step. So here's, both are cubics. You're going to have a quartic maybe to solve, and when it's a graphing calculator, it's not as difficult as it was with the factoring. Remember, and I'll put this off to the side or down here, okay, cubics. How many solutions will they have? Well, they have to have one because the graph exits in opposite directions. We talked about that property of cubics. So they will have, or there could be 1 to 3 solutions. You need to keep that in the back of your head. So if you end up with 4 solutions, you've graphed it wrong, or you've done something that doesn't jive. And if you don't have any solutions, you need to change your window because you haven't got the entire graph. So I'm just going to move that out of the way. So let's put it up here. All right, so how does this work? Graphing calculator. This is my BAC. I'm going to turn it on, and the y equals function, I don't know if I can draw on this today, will it let me? Yep. Y equals, this is where we enter our graphs. Close the ink layer, so we hit y equals, oops. Oh, I got to turn it on. I think it's a real calculator. Okay, y equals, and I enter this equation in, so 2x cubed, and I hope if you have trouble with this, I can give you help in class with the entry. You don't have to put multiplication signs in, we can just enter it as is. So now it's going to graph that function for us. So now we go in, we hit the graph button, and I'm going to hit it prior to going along and changing my window. I want to see what I can see first. So I'm looking at the graph, and I'm looking at the properties here, and I'm gonna maybe just trace it or set it into the my note here just so we can talk about it, or maybe not. It's not going to work today. But if you look at it, if you trace it here, you can see that it does this S-curve. So what this tells me is that because that S-curve is there in the whole shape, that it doesn't actually return. So there is no other, there's just the one solution. So it's just crossing the x-axis at one location right there. All right, so you hit second, so I'll point out the buttons. We're going to hit the second function button, and then you're going to hit the trace button, and that will get us to the calculation stage. Number 2 is your 0. This is what we're looking for, the zeros. So I will hit enter. Oops, get rid of the ink first. Hit 2. And it's going to ask me left and right bound. So left and bound, you can see my cursor moving back and forth. So it wants me to put the cursor on the left side of the x-intercept, which in this case means I got to go below the x-axis, and I'll hit enter. Next, I have to move the cursor to the right side, which is right here. And this is because the calculator guesses. It just goes through it's called an iterative process. So when I hit enter, I find that the roots it crosses at -2 and y-intercept or y value of 0. So what am I going to ask for on a test? I'm going to ask you to give me a sketch. So I'm going to see if I can do this. No, it won't let me do it at all. Well, that's fine. So anyway, I'm going to ask you to give me a sketch. So you're simply just going to, give me a sketch of the graph, and you're going to draw it the way it kind of looks. And you're going to tell me that, therefore, x is equal to, and there's only one solution, -2. So the sketch just gives me an idea of whether you entered it in properly and whether you had the windows set up right. And that's it. That's all there is to it. So the tough part here is remembering how to use the calculator. So you're going to have to practice that. On to the second example then. Going back to y equals, I'm going to clear that equation and I'm going to put the new one in. So x cubed minus 6x squared plus 6x plus 8. And I go ahead and graph it and see what I can see. And I see now that there are 3 possible solutions here. So 1, 2, and 3. So I'm going to have to do that 0 process 3 times. All right, so second trace, and I'm going to do 0, or number 2. So I'm going to find the first one. So I move to the left, enter. Oops, move it right, enter. And I find the first root is at -0.73. So x equals -0.73. Now I'm going to find the second one. Repeat, second, calculate, number 2. And we move the cursor now on the left. It's going to be on the left side, so that means in this case it's going to be above the x-axis. And move on the right side. So find the next one, and I find it to be 2.73. And finally, one last time, I'm going to be below because I'm on the left. You'll see these arrows appear above, right here. You want the x-intercept to be in between those 2 arrows. All right. So I'm going to hit enter one more time, and the last root is at exactly 4. Oops, give me back to the lesson. All right. And then I need to give myself a sketch. I kind of skipped that stage here because I was just writing down my solutions. So it looked something like that. There we go. So it's going to be just practicing with the graphing calculator. So here's the homework. A couple questions to work your way through. And like I said, it's just practicing with that graphing calculator. All right. So good luck. And if you have any questions with the calculator, let me know and I'll give you a hand. And like I said, you have access to them in class, and I'll explain where to get a version that will run on any computer. So you can also do this at home and try it with me.